9.3 Trigonometric functions of any angle. Let theta be an angle in standard position, and let xy, the ordered pair xy, be the point where the terminal side of theta intersects the circle, which has an equation of x squared plus y squared equals r squared. The 6 trig functions of theta are defined as sine theta equals sine theta is y over r, cosine theta is x over r, tangent theta is y over x, cosecant theta is r over y, secant theta is r over x, and cotangent theta is x over y. Okay, so all right here. So if I have my unit circle, I have my point xy. The radius comes from the center of the circle to that point, right? And we are going to have to find r if given a point. These functions are sometimes called circular functions, and let's go ahead and get started here. So, concept 1, evaluating trig functions given a point. Alright, so we're going to let negative 4, 3, that ordered pair right there, be the point of the terminal side of our theta in standard position. Evaluate the 6 trig functions of theta. Okay, so first things first, do we have r? No, we got to solve for r. So, what I know is that x equals negative 4, y equals 3, and then I'm going to plug it into this equation right here, the x squared plus y squared equals r squared. So, I have r squared equals x squared plus y squared, and if I take the square root of both sides, I get r. So r equals the square root of x squared plus y squared. Then if I plug in x and y, right, so r equals the square root of negative 4 squared plus 3 squared. That's the square root of 16 plus 9, which is 25. What's the square root of 25? 5. And only positive 5 because we can only have in length being in positive. Okay, so now I have my x, y, and r. And if I follow these 6 trig functions right here, I have my answer. So what is sine? Sine theta equals y over r. Y is 3, r is 5. So I got 3/5. Cosine theta equals x over r. That's negative 4/5. Tangent of theta equals y over x, which is 3 over negative 4, or negative 3/4. And then I'm also going to do these ones, so here we go. Cosecant theta equals r over y, in this case 5/3. Secant theta equals r over x, which is 5 over 4, it's negative, so negative 5/4, and cotangent theta equals x over y, which is negative 4/3. Okay, so you're going to have to refer back up here probably for a little bit so you recognize those. But there we go, that's everything. These are ratios, so they're fractions. And why don't you give number 2 a try? And I'll go ahead and show the answers. And are you ready? Pause now if you have not completed it. There are all the solutions for number 2. Alright, pause again. I'm going to go ahead and flip up to 3, so make sure you complete number 2, and then here we go. Concept number 3, using the unit circle. Okay, so the unit circle is x squared plus y squared equals 1, where r equals 1. Alright, the center of the circle is 0, 0, so always the origin, the radius is 1. The values of sine and cosine are simply the y and x coordinates respectively, and the point y where the terminal side of theta intersects the circle. So, just what we talked about in concept 1 here, sine theta equals y over r. Well, if r is 1, it's y over 1, which is y, right? So it's really always going to be the y value of the ordered pair. Cosine theta equals x over r, which is x over 1, if the radius is 1, right? And that is just x. So cosine theta is always going to be the x value of the ordered pair. You know, it's kind of reverse of what you normally would think, but that is the case. Okay, so using the unit circle. It says, use the unit circle to evaluate the 6 trig functions of 270 degrees. Okay, so I'm going to make a quick x. Okay, so it goes 0, 90, 180, and then right down here, right, is my 270 degrees. So if I go ahead and do this reference angle here, there is my point for 270 degrees. Okay, so what is that point right there? Well, it's 0, right or left, right, down 1, because r is 1. So 0, negative 1. Okay. So now I'm going to refer to those 6 trig functions, and I have sine theta equals y over r, and again r is 1, and then so I have negative 1, so it's y, right? Negative 1 over 1, which is negative 1, which was just that y value in the ordered pair. I didn't even have to do all that. I knew it was going to be negative 1 just by looking at that. And what's cosine going to be? 0, right? But I'm going to go ahead and show you anyway. Cosine theta equals x over r, which is 0 over 1, which is, again, 0. Tangent theta equals y over x, and y is negative 1, x is 0. Well, can we divide by 0? No, it's undefined. Okay, I'm going to keep on going here. Just switch up the marker. Okay, and now I have cosecant theta is r over y, which is 1 over negative 1, which is negative 1. Secant theta equals r over x, which is 1 over 0, which is undefined again. Cannot divide by 0. And cotangent theta is x over y, which is 0 over negative 1, and that would just be 0. Okay, so when we use the unit circle, r is always 1. So if it lies on the x or y axis, that's basically when we're using it. And in this case, you would just go down 1, so it's 0, negative 1, because the radius is 1. Alright, try number 4. That is 180 degrees. Again, it will lie on the x-axis. So, give it a try. Pause now, give that a try. I'm going to go ahead and show the answer. Okay. Pause that, continue to look at that. I'm going to move on to the next question. Okay. Reference angle relationships. Okay. So it says, let theta be an angle in standard position. Reference angle for theta is the acute angle formed by the terminal side. Okay, terminal side of theta and the x-axis. Always in relationship with the x-axis. Always. So it's the closest angle to the x-axis. The relationship between theta and the reference angle is shown by the non-quadrilateral angles such that between 90 and 360 degrees, or in radians 2 pi and, pi over 2 and 2 pi. So we're only talking about quadrant 2, 3, and 4 is what they're saying. All right, quadrant 1, we don't have to worry about it because the closest thing to your x-axis will, if it's in quadrant 1, is that initial angle or radian that's given. But if it gets into quadrant 2, then it would be on the other side of the y-axis, right? So it would be right here. In quadrant 3, it would also be over here, and then quadrant 4 would be on that same terminal side, but underneath it. Okay, so if it is degrees in terminal 2, then it's 180 minus theta. The reference angle for radians would be pi minus theta. Quadrant 3, theta minus 180 degrees. In radians, theta minus pi. And in quadrant 4, degrees would be 360 degrees minus theta would be my reference angle. And in radians, my reference angle is equal to 2 pi minus theta. Alright, so this is really important. We're going to have to come back and refer to this chart to really understand what's going on. Now, once you kind of grasp the idea, then you can just kind of look at where the relationship is to the x-axis. Okay? Alright, so here we go. I'm going to scoot on up. It says concept number 3, finding reference angles. Reference angle is the angle between the terminal side of theta and the x-axis, aka the horizontal line. Alright, so number 5, find the reference angle for A, theta equals 5 pi over 3, and B, theta equals negative 130 degrees. Okay, so let's go here, A, and my theta is 5 pi over 3. Alright, 5 pi over 3. So that is basically, so if I go up here real quick, it goes 0, half a pi, pi. This is 1.5 pi, and then back to 2 pi. So 5 pi over 3 is actually past this 1.5 pi, so it is in quadrant 4. So that's what I'm going to put. I'm going to put quadrant 4. Now, you could always refer to that unit circle that we have in our notes. Okay, so let me just do that real quick. Right here, that unit circle we have, here's 5 pi over 3. Right there, about 300 degrees. Okay, again, quadrant 4. Always refer back to that if you need, no problem. Alright, next is to find this reference angle. So I'd say reference angle equals, well, if I go to quadrant 4 in radians, it's 2 pi minus theta. So now I have 2 pi minus 5 pi over 3. Okay, and I'm going to just make common denominators. So I'm going to multiply both 3 to both top and bottom. So that will give me 6 pi over 3 minus 5 pi over 3. And now I can combine and I just get pi over 3. Okay, so my reference angle is pi over 3. And done. Okay. I'm going to just go one step farther here. If I went ahead and made a triangle, make a little graph here, I could. You don't have to do this. We have the answer. But just so you can see, if I did, there's my reference angle. There's my theta. It's 5 pi over 3. And then my reference angle would come from my x-axis right here. And that's my pi over 3. Okay, I'll do B on the second video.